Continuing on with our tutorials, I'm going to move on to fun with one-line transformations. Now, I do want to do, well, I guess I'll stay with the same script for this. And I don't know if I really want to have it keep printing all this out. So you can actually go up and do source, toggle block comment, and that will toggle all that off because it puts a comment line in front of it. Then just remember before you turn in your script to go ahead and toggle it back off again. And that will toggle an entire block of code on and off. Very handy when you're writing code. Now we're still going to need our paths and our imports. So let's go ahead and take a look at what this script has. First thing we're going to do is we're going to go ahead and show a country file path, spaview.show. Then we pass it a shapefile as we did before, and that'll bring up a window showing us what's in the shapefile. Very handy when we're working with spatial data. And then we're going to go ahead and comment that out. And then we're going to go ahead and buffer it. All right. So I'll go ahead and comment that out. Now we're going to go ahead and buffer it, but I really want to show that one. Let's show the new one. And I could either do that off of the folder path or off of the data set. And I'm going to go ahead and just copy some code and run it, and then I'll talk through it a little bit because I want to make sure it works first. All right, there's our countries buffered at 10, which would be 10 degrees because it's geographic data. Okay, not really realistic, but fun. Okay, so notice that the buffer command takes a country's file path. So we just send it a path to the country shapefile and then a buffer distance. The buffer distance is going to be in the coordinate reference system that our data is in. So this is geographic, those will be degrees. If you're in UTM, it would be in meters. If you were in state plane feet, it would be in feet. So we can actually change that, and let's make it a smaller buffer distance. Now, here's our file path for output. In other words, this is our input file path. We do a buffer, that returns us a new data set. Then we can take that data set and notice it says .save. So we want to save it to this output path, which is the output path for all of our files. Let's go ahead and take a look at that. There's our output path. They're all going into spa test/temp. Okay, and then we're adding a name for that shapefile at the end of it. So let's go ahead and try that. Oh, look, we buffered, but at a smaller distance. And now the other thing we can do is we can go into spa/test, temp, and it's missing because I'm in the wrong folder. There we go, spa/test, temp. There we go. So there's our different buffer shapefiles. And I welcome you to go ahead and load that into a GIS package to see how that's working. And as long as we're here, let's make it even bigger and see what happens just for fun. Change that, and run it again. And we get really big buffers. I think it's fun. Okay, so moving on through here. Okay, now one of the things we can do is we can do a whole bunch of different processes, different transforms using SpaPy. And when we ran this, you may notice that these are not actually union together, right? They're buffers, but they're individual buffers for every country. If you want to do something like find the 10-mile limit off each of the coasts, then we'd want to unify those together to have it look more like this. So that's simply a union transform. So now we can do our buffer, and then we can take that same buffer data set, we can do a union transform on it. That gives us a union data set, which we can then save to a shapefile, and we can also show it. We don't actually have to save it, but this is sort of the flow that I tend to work through when I'm developing Python code. So there's our buffers, and then we do a union, and there's our union. It's kind of weird like this. I'm going to go ahead and shrink our buffers down quite a bit. And notice we can play with it. It's pretty easy to change it up, and it runs really fast. So there's our 1 degree buffer. not very buffered at all, but you can still see there's some overlap and some strange things happening here in Europe. We go ahead and buffer that. Ooh, it takes a little bit longer to buffer, and now we have buffered for the whole world. Cool. Okay, let's see what's next. Alrighty, we can find centroids. Okay, before I paste in my centroid code, I'm going to go ahead and toggle block comment, get rid of the buffered code, and then I'll go ahead and paste in the centroid code. Now, centroid goes ahead and finds effectively the center of a feature, and I'm just going to go ahead and run this first. And we're sending it a country shapefile, and then it comes back with points that are in the center. Now, it's the center of a shape, so you might have islands, and the point isn't necessarily in one of the polygons, but it is in the center, really the center of mass, spatially, of the shape. Okay, and whenever you feel like, check out the temp folder to see that these are there. All right, what's the next one? Okay, so now we have a convex hull transform. Convex hull is used commonly in wildlife, especially for finding the range of animals from points. Again, I'm going to toggle block comment, get rid of that one. I'm going to run this on countries and see what we get. Okay, so you can see that what the transform does is it puts polygons that don't have any, aren't convex, so it doesn't have any, caves, or effectively, things like bays and things are all cut out, so it's smooth. So this is used to find ranges for animals. And that's it. And in each case, notice that we're just running the transform inside of SPA vectors. That gives us back a data set, and then we're saving that to a file, and then we're showing it. Now when we finish our code, we'll take out the shows, because that's really just for debugging. All right, let's go ahead and simplify. Now, yeah, okay, toggle block comment. And go ahead and run this one. Simplify is used a lot with complex data sets. I use it really frequently when I'm putting data up on the web, because you have to simplify the data. And notice how it took our nice shapefile and made it really jaggy. Simplify removes points based on some tolerance. So in this case, we've got 2 or 2 degrees. Let's go ahead and take that down to 1. See what that does. Okay, see it's not as jaggy. And if we crank that up to say 10, it's 10 degrees, 110 kilometers per degree, that's about 1,000 kilometers would be the tolerance. So it gets really jaggy and not really very useful unless you're into like Art Deco or something. Okay, let's go ahead and toggle that one out and go back and see what else we've got. Clip, okay. So this is kind of cool. You can clip out sections of a shapefile, and you can do that by specifying a bounding box for the shapefile. And so here we go, and we get just a section, okay? So let's go ahead and see what happens, if we do 150, 50 minus 50 minus 50. Each one of these is going to be a coordinate, and one of the ways we can tell what those coordinates are, so go 150. So this is our x max, right? Because this is 150 over here. And so I'm betting this is our x min, or the, yeah. Yep, so there's our x's. It's going to be our y's. Let's go ahead and make that like 80. Make this 0. Basically, you're getting the northern hemisphere then. And this is really what I'm looking for you to do, is to go ahead and play with these, run them in Wing, because I'm looking for you to get comfortable just with running the functions and feeling that you're able to run them. Now, we're not doing anything real yet, but we'll get to that in the very near future. Okay, and that's it. And we'll move on to overlay operations in the next video.